Okay, so let's make some contours here. We've already made the facing operation on this surface here across the whole part. So go to Tool Paths, Contour, select C-plane, and make sure you're in wireframe. And then we're going to select that chain. The reason we select C-plane is in this part especially, all of our operations can be done in the C-plane. It can be horizontal, in the horizontal plane, and we can flip the part over, it'll still be in the new horizontal plane. There's no strange 3D sections that we need to go up and down on. Okay, so let's zoom in here, and I'm going to select this line, and I'm going to select it on this side. The reason is when I select it on the right side, it's going to start from the right vertex and move in the left direction with the arrow. So you can see that that ended up happening, and it's hard to see. Let me zoom out. You can see that I have successfully got the chain to go all the way around. So that's exactly what I want. I'm real happy with that. The reason that I wanted to go left and not right is if you think about a climb mill cut, it's on the outside. If I were to select it in the other direction, going towards the right, climb mill cut would be on the inside of the part, and that's obviously not going to help us. Even though in Mastercam, you've got these solids all over the place frequently, but then you're doing what's not a solid operation. A contour is really, it doesn't know about all this stuff out there. It knows about this one chain. That's it. It doesn't know anything else about the chain, and it's just as valid to contour on the inside as it is the outside. So think about a climb mill and make sure the cutter's on the right side. If you get it wrong, and we can do this at the end of the video, it's easy to fix. So you can undo it easily, but it's the only thing easier than fixing it is never having to fix it. So I'm going to click OK, and then I'm going to go through here. Some of these things should be real basic, like 1/2 inch flat end mill or whatever end mill is appropriate for you. Holder, we did this before and we'll do it again. Cat 40, ER 32, doesn't matter what you pick, just pick. No, it matters what you picked. It doesn't matter how I pick it. You need to pick the right one. Cut parameters on the left side. You see, it's not climb. It's not conventional. It's on the left side because it Mastercam doesn't have the solid model. It can't understand if it's on the inside of the part, outside of the part, if it's valid cut or not. It's just the left or the right. And when you get into G-code, when you're looking at things like tool offsets and radii, the concept is left or right. It's not climb or conventional because in basic G-code there's no concept of climb or conventional because G-code isn't sophisticated enough to have that information in it. It just knows which side it's trying to be on. Now if we were going to do a rough pass and then switch tools and go to a fine pass or finishing pass, we would want to leave some material on the walls. We're going to do a combination rough finish with one tool, so we're not going to leave any material on the walls. We'll just specify it later on. So I'm going to go to depth cuts. We're going to use depth cuts, and what that is when we start cutting here, we don't want to cut all the way down in one pass. That's just going to be too deep on this part. And for that matter, you don't really have to know if it's too deep on this part. You just specify the max rough step, and if let's say our part was only 1/4 inch thick, it would do it in one pass. No big deal. Just specify the appropriate max rough step, and Mastercam will figure out if that's 1 pass or 2 passes or 100 passes. Finished cuts. I'm not going to use it, but I'm going to show you how to enter it. So if I put one finish cut, and let's say it's a 10th finish cut, that makes a finish cut on the floor. So the floor here is open space. I don't want to spend a bunch of time making a beautiful cut on open space. It's a waste of time. So I'm going to set that to 0. That's going to turn it off, the 0 cuts. Lead in, lead out. Use this all the time. This makes the start and end point of your contours, it keeps it from having a bump as you bore down, and the imperfection of some machining and deflections and all that sort of stuff will leave a little bump there. The lead in, lead out will, just like in this picture, it'll come on an arc and then go tangent to the contour, and it's a good way to do it. If you are really pressed for space, you can play with these lead in, lead out, the arc and the straight length that you approach. You can make much smaller. There's no reason why they need to be quite this big, but in a big part like this, we're not pressed for space, and that's probably fine. Breakthroughs. If you're drilling a part, you definitely need a breakthrough, and we're going to need a breakthrough here for a similar but not exactly the same reason. When we machine down this part where I'm showing the cursor, when we get to the bottom, if we stop exactly at the height of the chain, which is really all we care about, when we flip the part over and machine the other side, in all likelihood we're going to leave a burr, because the aluminum will get pushed out of the way by the cutter, especially when it's real thin, and that's no good. So if you cut a little bit too far past it, when you come on the other side and clean up the back side, then you'll get a nice clean cut. So we're going to leave, let's say go 50 thou too far. Now you definitely don't want to do it when you're machining something like this step here. That's if you machine with a breakthrough on that, it's just going to be too far down. But here, where you're machining out into the open world, the black space there, that's where you really want to use breakthroughs. And for that matter, use them a lot in holes. And if you think about it as machining into black space, well, you're machining into black space in the holes also. So I'm going to use a breakthrough there. The multi-passes, this is the concept of the lawnmower effect, where you start on the outside and you keep going in by a certain amount, in further and further and further. Now I'm going to use this, and I'm going to put in 2 passes. And the reason I'm going to use this, I'm going to put 3/8 of an inch just as a nice easy number. The reason I'm going to do this is if you make a big deep cut and you don't do a multi-pass to give it some width, some clearance for the cutter, then what's going to happen is you are going to get chips packed in there. The cutter's going to rub. Everything's going to get hot. In aluminum, when things get hot, the metal will stick to the cutter, and that's bad news. So you don't want any of that. You want to give some space. Two passes here probably will do it. You might want to do more, and you'll see and verify exactly what this looks like. One of the things to keep in mind in CNC is just because you can make a pretty picture does not mean it's a realistic cut. You do have to deal with coolant. You have to deal with letting there be space for coolant to get into the cut. You have to let there be space for chips to exit the cut and be washed out by the coolant. If there's not sufficient space, you're going to have a problem. Chips are going to pack, and just because it says CNC in the front of your machine doesn't mean it's going to automatically make the chips disappear. You'll see in the verify there's no chips. It doesn't understand that concept. And then we're going to do a finish pass, one finish pass at 10 thou. And what's the reason that we're going to use a finish pass and not we're going to use a finish pass here and not on the floor? Because we're going to keep the side. The side here we're keeping, so we want to have a nice pretty finish on this. We want to make sure this is a keeper, so we want to make it look good. So one extra pass 10 thou deep will make things nice and pretty. If you're having real good luck with your roughing pass with a high quality cutter, skip the finish pass. It'll make it faster. But finish passes are usually a pretty easy way to get nice finishes and get things accurate. It doesn't work in every case, but it works in lots of cases. Now, linking parameters. Here's a super important part. So let's select the depth. I think it's right just from the chain, but I never trust that. So what's the depth? Here's the deepest part we want to cut, ignoring any breakthrough. Right there, I'm going to select that. There's a whole bunch of pieces we could have selected. They're all the same height. Top of stock. This is where we start cutting. So we need, is top of stock, is it here? No, it's not here. This is top of the picture, pretty picture we're looking at. It's not here, and it's not here. Top of stock is here, because in the last video we faced it this high. So the material no longer exists above this. It started out even higher than this, but then we faced it to this height. This is now the top of stock. So I'm going to select that height. You can see the point from where we selected that. The reason why the top of stock is important is whenever it does machining, it will go into a cut mode where you're going at a controlled feed rate instead of a rapid by the point where you get to top of stock. It's very important that you do not enter the part in a rapid mode unless you're cutting something like plastic or wood that can actually be cut at the maximum speed of the machine, but realistically you're not doing that too often, or you're probably not doing that too often. And so specify the top of stock, and then the feed plane here is 1/10 of an inch above the top of stock. We can specify it as absolute number, but incremental is actually really convenient. It just says always when the feed plane is where the height that the tool goes to when it's going back and forth between different cuts. It's not cutting, it's getting out of the part and it's moving to another cut. That's the feed plane. 100th thou over is a good height. And then retract when you're starting and stopping at the beginning and ends of operations. At 0.25 is well above negative 0.35. You could do an incremental over the feed plane, but a lot of times it's just nice to have some consistency to at the height that the cutter will go to at the beginning and end of the move. It's up to you though. These things can be different for different people because different people have different ideas on how they're set up. But the key thing is look at them all, make sure they're not gouging the part. Make sure you understand what each one of these is. And the last one, turn on the coolant. Probably going to use it, since this is an aluminum part, we'll probably use coolant for all operations. And you say OK. There we go. Looks good. Let's not just congratulate ourselves on getting pretty blue lines. Let's actually look at them and sanity check them. You can see the bottom blue line is slightly below the part, so we told it to break through 50 thou. That seems reasonable without measuring it. We start below the top of stock, but it looks like it's about one cut depth below the top of stock, so that seems reasonable. Now let's look at the top. It looks like it's going around the part. We've got 2 passes. We don't have 3. What's going on with the finish pass? Where'd that go? So if we look in really close, let me try to get this easy to see. You can see that we have, here's our rough pass, here's our finish pass, or here's our second rough pass, and there's actually a finish pass if you zoom in close enough. So that's just fine. It just we weren't zoomed in far enough to be able to see that finish pass separate. So that looks like a good one. That's a keeper. Now what I'm going to do is I'm going to turn off that toolpath, and I'm going to show you an example of selecting the chains incorrectly so we can understand how to deal with a problem. So I'm going to C-plane, I'm going to do another contour, C-plane wireframe. I'm going to zoom in, and I'm going to intentionally select the chain incorrectly. So I'm going to start on this side. And this is starting on the left, going towards the right. And what's that do for us? If we think about what's a climb cut is on the inside here. Or I was thinking about climb cuts here. So climb cut on the inside, that's not what we want. That's no good. That's going to make a really bogus toolpath. It's going to cut the inside of this part, which is not what we're trying to do. So let's say OK, just to get a reality check, and I'm going to skip all this stuff because this is just a demonstration of what not to do. And look at that, we got a really bad, look at that, that thing is going to make a mess. It's going to start chopping through the part. Now, if you do this, do you need to delete this operation and start from scratch? You don't. So what you do is you go in here and select your geometry again, and you can see we're going in this direction, and actually we get a second arrow that you don't see when you chain it. I don't know why you don't see it when you chain it. It's telling you which side you're on. So we're going to be on this side, and naturally we'll be climb cutting. So what we can do is we go and right click on the chain. Let me get back to where we can see how I got there. Click on the geometry, right click on the chain, and what I'm going to do is I'm going to change sides. Now watch this small arrow, which tells us the side that we're cutting on. Change side, there we go. Now we're on the right side. But notice, for some reason, Mastercam's not smart enough. It didn't change the direction that we're cutting. I guess we told it the direction, so it's just listening to us blindly, even though we were dumb in the first place. So now we're going to get a conventional cut. If you are making a really wide cut width, cutting steel or some material that's real tolerant to a conventional cut with a good surface finish, that's great. If you're cutting in something that's not going to tolerate that conventional cut and you want a climb cut, this is still not acceptable. Now you're on the right side, getting better, but let's change the direction. So what you do is you right click on that chain and reverse chain. So that double operation of changing sides and reversing chains will fix a messed up chain. I'm going to say OK. And now we got a dirty tool path, so I'm going to regenerate my dirty tool path. And there we go. So we're looking pretty good here, except for one thing. You notice that our lead in, lead out disappeared on us because our lead in, lead out doesn't make sense in that corner. So let's go back in here, and realistically, let's see, what can I do? I can right click here and let's change the start point. I can tab around, so it'll jump vertex to vertex, and now this has got more room for the lead in, lead out. I prefer that Mastercam was smart enough to figure out how to deal with that, but oh well, this isn't too tough to change the start point. Okay, and let's redo the dirty operations, and sure enough, we've got ourselves some lead in, lead out that look completely reasonable. So that took us, what, a minute to go fix that purposely incorrectly chained situation. It's only a minute, but these things add up. You're going to do this piece is probably going to have 20 operations or something like that. You don't want to fix this 20 times. So take the extra few seconds and chain it right the first time, and you'll be in better shape. So I'm going to delete this guy. And I say yes, and then go back here and we'll see. Here's our original chain. Our second new one looked exactly like this after we fixed it, but this one was right from the beginning. And let's go and select the whole group. Let's verify it, and let's run this thing. Positive end of operation. Note that I always have stop on collision. Mastercam determines that you're trying to cut during a rapid move or hitting with your tool holder. It'll stop and warn you. And the other one I do is stop after each operation. If I think that this is going to be fast and I'm not going to catch everything, I'll turn on stop after each operation and it'll stop. I'll be able to look at it, get my bearings, and keep going. So I'm going to say OK. Oops, that's not what I wanted to do. Let's try this again. Hit the wrong button. And then I'm going to hit play again. That should hit play, not OK. And so you can see here, cutting away, outside pass, finish pass, outside, inside, finish, outside, inside, finish. There we go. So notice we have a nice wide path here to get some chip flushing with the coolant. Maybe that's wide enough, maybe not, but those are the extra paths we did there with the lawnmower effect. And if we wanted to do more, we could go and change that. If we want to refresh our memory, look at parameters, multi-passes. If we change this to 3, it would be even wider. But the important thing is we understand how to make this wider or narrower by making more or less multi-passes at the spacing that you want that's appropriate for your cutter. Okay, so next video we will be doing the contours here.